everyone, in this opportunity, we want to present our essay about the potential of medical PPE waste as fuel to overcome environmental problems in the new normal era. Before that, I want to introduce our group. My name is Idhea Pryas Islami from Department of Chemistry Universitas Negeri Semarang, and my partner Cornellia Permata Desta is also from Department of Chemistry Universitas Negeri Semarang. We divide our presentation into several chapters. They are introduction, problems, goals, solutions, discussions, instrument, and conclusion. The COVID-19 pandemic is a complex problem faced by the world community nowadays. Various aspects that support the continuity of human life are being totally affected, such as economic, social culture, education, and environment. This is due to COVID-19, which is very contagious. It transmits through droplets and airborne. Thus, people and particularly medical personnel must wear PPE or personal protective equipment like face masks, face shield, and gloves. The continuous use of PPE will lead to the accumulation of PPE waste. This is because PPE is only used once. Reported by several news reports, millions of PPE trash built up at sea. In June 2020, in Surabaya, PPE was scattered in public cemeteries. In landfills, a lot of PPE waste has built up and mixed with other garbage. According to ADB's estimates, Jakarta could produce 12,720 tons of disposable gloves, gowns, face masks, and intravenous therapy bags in 60 days during the peak of the virus. Imagine, ladies and gentlemen, if we calculate that we produce PPE 212 tons waste per day. Our SPI Director Sulianti Saroso, Muhammad Syahril, admitted that the increase in the medical waste after COVID-19 was indeed quite significant. He said on average, one positive confirmation patient produced 20 PPE or personal protective equipment. Quite a few PPE are used to treat patients in isolation rooms. The PPE waste that SPI destroyed in February was 130 kilograms, and last March increased to 500 kilograms. The hospital burns after storing PPE for 2 times 24 hours. So, in the problems we face, we have a goal, namely to decrease medical PPE waste and turn it into fuel. The question is, how? PPE contains types of plastic polymers such as polypropylene, polyvinyl chloride, and polyester. So what? The good news is we can convert them into fuel using the cracking method. Examples of PPE that can be used are masks, face shields, hazmat, and gloves.
Cracking is the process of breaking polymer chains into compounds with lower molecular weight. The result of this plastic cracking process can be used as a chemical or a fuel. The product of cracking include alkenes and alkenes, members of a different homolog series. This process is assisted by using heat to break down the chains. There are 3 types of cracking process, namely hydrocracking, thermal cracking, and catalytic cracking. Hydrocracking is basically a cracking process where the plastic is reacted with hydrogen in a closed container equipped with a stirrer at temperature between 400 until 600 Kelvin. Thermal cracking includes the pyrolysis process. The method is by heating the polymer without oxygen. Heating is usually carried out at a temperature between 600 Kelvin to 1000 Kelvin. Meanwhile, catalytic cracking uses a catalyst to carry out the fracture reaction. With the catalyst, it can reduce the temperature and reaction time. PPE waste is put into the combustion reactor and heated at a high temperature. After that, the steam will rise and be cooled to the condenser. Each condenser holds the liquid with a different vapor point. Hydrocarbon vapor heavier with longer chains is accommodated in the condenser 1, and the lightest hydrocarbon chains is accommodated in the condenser 3. Each condenser will produce different type of fuel. UNNES have conducted research on polypropylene and high-density polyethylene pyrolysis using silica alumina as a catalyst. The result is that polypropylene plastic can produce 90% purity at a reaction temperature of 500 degrees Celsius. Furthermore, KIME perform pyrolysis using FC catalyst. The result is that PE, HDPE, PS, and PP plastic produce more than 80% purity of fuel. So, in our study, we conclude that PPE waste contains many types of plastic polymers such as polypropylene, polyvinyl chloride, and polyester, which can be used as a raw materials for making fuel. By using the method of converting PPE waste into fuel, it will be a solution to dealing with environmental problems that arise after the COVID-19 pandemic and in the new normal era, and is also useful for converting the use of value of hazardous waste into something more valuable. That's all our presentation today. Sorry if there are things that are not pleasing for you, and I want to thank the committee for organizing this event, and see you.